This is problem number 15 on equilibrium of forces. So we have to determine the reactions at contact points of spheres A, B, C. Okay, there are contact surfaces P. There is contact surfaces P at P, K, L, M, N, and O. At all these contact surfaces, we have to determine the reactions. Okay, and weights of the spheres are given. WA and WB is equal to 4 kilonewton. Weight of sphere A and B is 4 kilonewton. Weight of sphere C is given as 6 kilonewton, and diameters are also given. Diameter of sphere A is A and B is 500 mm, and diameter of sphere C is 800 mm. Okay, so here we'll write reactions at all the contact surfaces first. So reaction at contact surface P will be Rp, which is always perpendicular to the plane of support, and reaction at O will be Ro. Then for sphere A, there will be reaction from sphere C, and for sphere C, there will be reaction from sphere A, and both are equal and opposite to maintain the equilibrium, that is Rk. Therefore, reaction at contact surface K is Rk. Similarly, for sphere C, there will be reaction from, let me join these 2 points directly. Okay, for sphere C, there will be reaction from okay, just a minute. Okay, so for sphere C, there will be reaction from sphere B. For sphere B, there will be reaction from sphere C. So that is RL, and both the reactions are equal and opposite to maintain the equilibrium. Okay, and for sphere B, there is contact surface N. Let me write the reaction at contact surface N, that is Rn, and at point M, reactions are at point M is Rm. Rm. Okay, now we have to determine horizontal inclination of all the spheres, right? Means all the inclined reactions. For that, you draw one horizontal here, one horizontal here. Here also you draw one horizontal here. Then angle of this plane with the x-axis is given as how much? 65 degree. 65 degree. And angle of RM with the plane is 90 degree. Therefore, the remaining angle is 25 degree here. Correct? And similarly, at RP, inclination of the plane with the horizontal is 75 degree. 75 degree. So the remaining angle 90 minus 75. The inclination of RP with the plane is 90. 90 minus 75. It will be 15 degree here. So here it is 25 degree is the horizontal inclination of the RM. Okay. Then coming to the horizontal inclination of RK. RK that we have to find, right? That we have to find. Here the overall length from here to here it is 600 mm. Therefore length AD will be how much? It will be 300 mm. 300 mm. Now you got length AD. You can also find length AC. Length AC. Length AC will be equal to what? Radius of sphere A plus radius of sphere C. Okay. Radius of sphere A is, for sphere A, diameter is given as 500 mm. Radius becomes 250. Okay. So let me write the dimensions here. Okay. Okay. No problem. Here only I'll write 250. 250. Radius becomes 250. And for sphere C, diameter is 800 mm, radius becomes 400 mm. 400 mm. Therefore, from the figure, length AC will be equal to 250 plus 400. Correct? From figure, length AD is equal to 600 by 2, that is 300 mm. Then length AC is equal to 250 plus 400. 250 plus 400, you will get the answer as 650 mm. 650 mm. Okay. Now you can calculate the inclination of RK with the x-axis. I will take right angle triangle ADC from right angle triangle ADC. ADC. You can measure cos theta now. Cos theta is equal to adjacent by hypotenuse AD by AC. AD by AC, which is equal to AD is 300 by 650. Therefore, theta is equal to cos inverse of 300 by 650. Therefore, horizontal inclination is 62.51 degree. 62.51 degree. Let me write that angle there. Horizontal inclination of RK is 62.51 degree. Okay. Now we are able to find horizontal inclination of all the spheres. Here also same angle you will get. You will get the same angle because radius of sphere B is same as radius of sphere A. So you will get the same angle, 62.51 degree. Okay. The RL. Now calculation of the angles is over. Next step is to select the sphere. So you have to select the sphere in such a way that there should not be more than two unknowns. If you select sphere A, for sphere A, reaction at P is unknown, reaction at O is unknown. There is reaction from sphere C to the reaction to the sphere A. So there are three unknowns for sphere A. Similarly for sphere B, RM, RN and RL, three unknowns. Therefore you select sphere C. You can see that for sphere C only there are two unknowns, RK and RL. Okay. Now sphere C. Sphere C. Sphere C. Select sphere C. For sphere C you write the free body diagram now. For sphere C the self weight is given as 6 kilonewton. Okay. 6 kilonewton. WC. WC is equal to 6 kilonewton and WA, WB 4 kilonewton. Here it is 4 kilonewton. So 6 kilonewton force always it will act in vertically downward direction along the direction of gravity. Write that force in downward direction. 6 kilonewton force. Now for sphere C there is reaction from sphere A, that is RK, in right top corner like this, RK, and horizontal inclination of RK is 62.51 degree. And for the same sphere C there is reaction from sphere C, that is RL, in the along the direction of along the left top direction, RL. Here also we have the same angle, that is 62.51 degree. Okay. Now on this side overall angle is 90 plus 62.51, 152.51 degree. On the other side this overall angle is 152.51 degree. So the remaining angle 360 minus 152.51 minus 152.51, you will get around 55 degree. 55 degree. Okay. Now applying Lami's theorem, RL divided by sine 152.51 is equal to 6 divided by sine opposite angle 55 is equal to RK divided by sine 152.51. Okay. So considering first and second equation you will get RL, second and third equation you will get RK. RL is equal to 6 sine 152.51 divided by sine 55. By this you will get reaction at L, that is 3.382 Newton. Okay. So from second and third equation RK is equal to 6 sine 152.5 divided by sine 55. Same equation you will get. Therefore you will get the same answer for RK. Therefore RK is equal to 3.382 Newton. Okay. Now we got RK and RL values. Let me write those answers here. 3.382 Newton. Newton. 3.382 Newton. Okay. Now you can select either sphere A or sphere B. For both the spheres only two unknowns. For sphere A, RP and RO are the unknowns. RK is already we have calculated by considering the sphere C. Initially I will consider sphere A now. Sphere A. For sphere A, we will write the free body diagram. For sphere A, what is the self weight we have? 4 kilonewton, which is in downward direction. 4 kilonewton. Then there is reaction at point P in along right top direction with an angle of 15 degree. RP with an angle of 15 degree. Then for sphere A there is reaction from sphere C. For sphere A there is reaction from sphere C, that is RK along bottom left direction, RK, and its value we already know, it is 3.382 Newton. And horizontal inclination of RK is 62.51 degree. 62.51 degree. Okay. And there is reaction at contact surface O, which is acting in upward direction, RO. Okay. So to this writing the free body diagram is over. Now we have to apply equilibrium conditions. Okay, you cannot apply Lami's theorem because there are four forces. Lamy's theorem is applicable only for three concurrent forces. Horizontal component of RP is RP cos 15. Vertical component is RP sin 15. Here horizontal component of 3.382 Newton is 3.382 cos 62.51. Vertical component 3.382 sin 62.51. Now apply the first equilibrium conditions. Applying sigma fx is equal to 0. First equilibrium condition sigma fx equal to 0. Therefore it is minus 3.382 cos 62.51 plus rp cos 15 is equal to 0. Only there are two horizontal forces here. Okay, 3.382 cos 62.5 and rp cos 15. So I have added both the forces. By this you will get the value of rp. Rp value that you get is 1.723 Newton. Okay. Now go for the next equilibrium condition. Sigma Fy is equal to 0. Sum of forces in y direction is equal to 0. So we have 3.382 sin 62.51 acting in downward direction. Sin is minus 3.382 sin 62.51. Then we have RO force which is acting in upward direction plus RO. Then we have RP sin 15 acting in upward direction, RP sin 15. Then we have 4 kN force acting in downward direction, minus 4 is equal to 0. Now we got the value of RP. Substitute the value of RP in this equation. Minus 3.382 sin 62.51 plus RO plus RO. RP is equal to 1.723 plus 1.723 sin 15 minus 4 is equal to 0. By this we will get the reaction at O. The answer is 6.27 kilonewton. Okay. Now we got RP and RO. Let me write the answers. RP is equal to how much it is? 1.723 Newton. 1.723 Newton. RO is equal to 6.27. Sorry, it is not Newton, kilonewton. And RO is equal to 6.27 kilonewton. 6.27 kilonewton. Okay, this is kilonewton here. Now the remaining sphere is sphere B. Consider sphere B now. Write the free body diagram similar to the sphere A. Sphere B. Sphere B. For sphere B, the self weight is similar to the sphere A, that is 4 kilonewton. Self weight is 4 kilonewton, always in vertical downward direction. Kilonewton. Then for sphere B, there is reaction from sphere C, that is RL, which is along bottom right corner. With the same direction, I will write RL. Correct. RL value is known. It is 3.382 kilonewton. It is kilonewton. 3.382 kilonewton. Then for sphere B, there is reaction at N in upward direction, Rn, and horizontal inclination of RL is how much? We got it as 62.51 degree. 62.51 51 degrees. Then for sphere B there is reaction at contact surface M Rm at an angle of 25 degree and along left top direction like this. Just a minute. Okay. So reaction at M along left top direction and horizontal inclination of Rm is 25 degree. 25 degrees, and we have reaction at N in upward direction. Rn in upward direction. Rn. Rn. Okay. Now write the components for inclined forces. 3.382 cos 62.51. Vertical component is 3.382 sin 62.51. For Rm force, Rm cos 25, vertical component is Rm sin 25. Now apply equilibrium condition. First equilibrium condition, sigma fx is equal to 0. Therefore minus Rm cos 25 plus 3.382 cos 62.51. Only two horizontal forces are there, so we have added both the forces is equal to 0. By this you will get the answer for Rm, that is 1.722 kilonewton. Okay. Now go for the next equilibrium condition. Sigma Fy is equal to 0. Sum of forces in vertical direction is equal to 0. Therefore it is plus Rm sin 25 plus Rn, then minus 3.382 sin 62.51 minus 4 is equal to 0. Rm value is known, we have calculated that value is 1.722. Substitute here 1.722 sin 25 plus Rn minus 3.382 sin 62.51 minus 4 is equal to 0. By this we will get reaction at contact surface N. The answer is 6.272 kilonewton. 6.272 kilonewton. Now we got reactions at M and N, contact surfaces M and N. Let me write the answers. Rm is equal to 1.722 kilonewton, and Rn is equal to 6.272 kilonewton. 6.272 kilonewton. Okay. So to this we have determined reactions at all the contact surfaces O, P, contact surface K, L, M and N. Okay. We got the answers for reactions at all the contact surfaces. Okay. So this completes the problem. Thank you.